understand the climatic conditions of a particular environment, that will be quite interested. And then, of course, calcine clay. And in Europe are changing the mindset towards permitting more and more of these kind of ternary and quaternary combinations. These performance-enhancing technologies, such as graphene, they might have some potential. So I'm not sure if you're familiar with graphene. It's a very strong material in the 2D, in 2D, and it's somewhat similar to carbon nanotubes. We are involved heavily with the development of graphene-based innovation for concrete, graphene-enhanced concrete. And the principle is that with these kind of very, 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 very fine graphene particles, we can build a strong network that improves the mechanical performance of the concrete. And specifically, it improves the flexural and tensile behavior. So for a particular strength, we can reduce the cement content required, and as a side effect of that, there's also benefits across permeability and durability, but it's still work in progress. So another thing is that graphene is currently expensive, so we don't know how scalable that will be in the future. The traffic light system is in terms of potential for adopting it in the future, again, with reference to decarbonizing concrete and reducing concrete's body carbon significantly. And as we said, the landfill fly ash, I have my reservations. I don't know if it will work. Perhaps a good idea is to look to produce concrete of low quality, low strength with landfill fly ash, perhaps even on the same kind of fashion that our colleagues in America treat fly ash, in terms of good quality, bad quality. And then if we get in the world of alkali activated materials, a lot of money has been spent, public money and research money on this field, and it's very exciting, I would say, technology with respect to chemistry and what we can do out of it. But perhaps 80% of the research out there is based on GGBS and fly ash, and these are materials we already fully utilize in construction anyway. One point is that. And secondly, what will happen when they will run out? Because eventually, at some point over the next 10 years, or maybe I'm saying many years, they will run out. Blast furnaces will be phased out, will be replaced by electric arc furnaces, and coal-fired power plants will be shutting down one after the other. They already do. So basing research and practice on GGBS or fly ash-based alkali activated materials and geopolymers, to keep Davidovich happy as well, it's a bit problematic in more cement or carbon negative cement or carbon negative